Hello everybody, am I audible to you? Hello everybody, am I audible to you? Hello, my voice is clear to you guys? Yeah, please let me know that my voice is clear to you or not. Hello, my voice is clear to you guys? Please let me know that my voice is clear to you or not, and किस किस ने क्लास को ज्वाइन कर लिया है, please let me know so that we can proceed in our class and we'll continue our class. Okay. Any doubt from previous lectures? If you have any doubt, you can ask. If you have any doubt, you can ask. Whatever we discuss tomorrow, if you have any kind of doubt, you can tell me, guys. So first we will discuss your doubts, and after that we'll move forward. And I think अभी बाकी लोगों ने ज्वाइन नहीं किया है, so please you can join the class as soon as possible. Yeah, Mohammed. So any doubt, Mohammed? Any doubt? Is there anything which you want to discuss? Please let me know. Okay. So what we discussed previously, we discussed the various temperature scales, and we have discussed that there are different types of the scale. Based on that, we basically measured the temperature, right? Some famous scales are degree Celsius, Fahrenheit and Kelvin, and some are Reaumur and Rankine. Okay, the thing that value is constant for all the scale, that this is the formula, and I told you that this is the simple formula, also very important. You can convert any scale into the another, or you can solve any faulty thermometer problem based on that, right? So you should have remember this formula, right? Okay, so like we have discussed a conversion between the degree Fahrenheit and degree Celsius. So this is my conversion formula, that is F is equal to 9/5 C plus 32, right? Is it clear to you? Okay, this question you are not getting this question. Okay, no worry. After that, we have done a faulty thermometer problem, right? That faulty thermometer reads a freezing point and boiling point of water is this, and we should calculate the actual reading when the faulty meter shows the 60 degrees Celsius, right? So if we have the two fixed point like the freezing and the boiling, then we can solve any question based on this concept, right? Just we should remember only one thing, that this parameter, this particular ratio is constant for every scale, right? And for every thermometer, whether it is actual or whether it is faulty. After that, this is the question, and Muhammad, you have the problem in this question. So let's discuss this question. So we have a formula F is equal to 9 by 5 C plus 32, right? This is the basically formula for the conversion from Fahrenheit to Celsius or Celsius to Fahrenheit, right? Okay. Question is saying that at what reading the Fahrenheit and the degree Celsius scale showing the same reading. Same reading means the same number. Is it clear to you? So we have to calculate that particular number that is basically same for the Fahrenheit scale and same for the degree Celsius scale. This is the question only. Okay, then just let's suppose that number, that reading is X. This X reading is showing by the Fahrenheit and also this reading is showing by the degree Celsius. Now we have to calculate this reading. Just put the value of F and C here. What is that value? X, which is we want to calculate. So instead of F it is X is equal to 9 by 5, and instead of C it is also X plus 32, right? And we just calculated here the value of X. So if you solve this simple mathematics, then you will get X is equal to minus 40. So minus 40 is the reading which is same for the Fahrenheit and same for the degree Celsius. Is it clear to you, Muhammad? Is it clear to you now? Is it clear to you? Okay. So previously in the last lecture, हाँ जी बोलिए बोलिए. So in the RMS side means, what is the meaning of RMS? This one? Yes, today we will discuss this thing. Today we will discuss thing. Don't worry. I'll explain it today. See, okay. So today let's discuss a very common term which we used in the thermodynamics, that is called absolute zero temperature. Absolute zero temperature. What is the meaning of absolute zero temperature? Just try to understand it. See, so I'm saying that this is any cylinder or any confined vessel, and gas molecules are filled in this confined space. Right? Let's suppose we are giving some heat to this system. By absorbing the heat, these molecules is basically going here and there. Already the motion of the molecules are random. Like this molecule can go here, it can go here, like that, right? So the motion of the gas molecules are already random. When it absorbs the heat, you can see the energy of the particles are now more. Now they are moving randomly with more energy, or you can say they are moving aggressively now, right? So we can say that the randomness of the molecules is basically increasing. Why it is increases? Because it absorbs some energy. Is it clear to you, right? So obvious, it is so obvious that if we are giving heat, or if the randomness of the molecules is increasing, it means the temperature of the body is basically increasing, right? So we are understanding this concept from heat to temperature, like that we are giving some heat, molecules absorb this heat, with the higher energy they are moving here and there with more, with the, you can say that more aggressively, right? It means that randomness of the molecules is increasing, right? And we can say the temperature is increasing. If we study this in the reverse manner, then we can say that if temperature is higher, then we can say that randomness of the molecules is increasing, right? Means the higher temperature, high randomness in molecules. High randomness means that now molecules moving here and there with a higher velocity, actually, with a higher velocity, and that velocity is called root mean square velocity, VRMS. So if we connect this velocity, which velocity, root mean square velocity, with the temperature, then the formula is VRMS is equal to under root 3RT by M. This is the actually formula, right? So at a particular temperature, what is the root mean square velocity? We can calculate it. We can calculate it, right? So here this is my root mean square velocity of the molecules, and R is my gas constant. R is nothing but it is my gas constant, right? Universal gas constant, and M is my molecular weight of the gas. Is it clear to you? So now we connect our temperature to the randomness. So we cannot, we don't have any, you can say the particular parameter to measure the randomness. So how we measure the randomness? Through the velocity. Okay. So it means, see, VRMS here, can we say that VRMS is directly proportional to the under root T? So if T increases, my VRMS will increases, or you can say randomness will increases. So if my T will decreases, randomness will decreases. Is it clear to you? So if you are basically, you can say that temperature is going down, it means the randomness in the molecules is basically going down. Why? It means that heat is rejecting to the system now. Heat is rejecting to the system. It means slowly the molecules have the energy, the energy of the molecules will slowly decreasing. This is the meaning, right? So at a particular temperature, a temperature is reached. At that temperature, molecule is about to dead. Molecule is about to dead means that now molecule is ceased to motion. इसका मतलब है that now molecules will not go here and there. Is it clear to you? Is it clear to you? Yes or no? Right? Is it clear to you? So that temperature is called absolute zero temperature. That temperature is called, guys, absolute zero temperature. So if you will take T is equal to 0 Kelvin, then put here T 0, VRMS is 0, VRMS is 0, VRMS 0. It means, what is the meaning? It means there the velocity of the molecules are 0. It means the molecules are not going here and there. Means that motion of the particle is ceased. So at 0 Kelvin, see, this is not 0 degrees Celsius. Absolute zero temperature is 0 Kelvin. Is it clear to you? So at this temperature, which is my 0 Kelvin, molecules, or you can say motion of the molecules ceased. Motion of the molecules ceased. So this is called my absolute zero temperature. So what is the definition of the absolute zero temperature? The temperature at which motion of the molecules is ceased. Right? What is the value of the absolute zero temperature? 0 Kelvin is the value. 0 Kelvin is the value. Is it clear to you? Please let me know that this is clear to you or not. Yeah, Anushka is there. Anushka is there or not? Anushka, Purnima. कौन है क्लास में? Let me know through a message. Let me know through the message, guys. Yeah. So absolute zero temperature means the temperature at which molecules are not moving, or you can say motion of the molecules is basically ceased. Is it clear to you? So molecules are almost dead, right? Molecules are almost in the state of dead. Am I clear with this? Right? Yeah, Muhammad. Now got my point, what I'm trying to say? What I'm trying to say now, my point is clear to you? Is it clear to you? So molecules are almost dead, right? Molecules are almost in the state of dead. Am I clear? I think voice is clear to you guys. Okay. Please put the next heading triple point. Triple point. So, what is the definition of the triple point? The definition is very simple. That the temperature at which all three phases, right? So generally we studied the three phase now. Which one? Solid, liquid and gas coexist. The temperature at which all three phases are coexist. Is it clear to you? In the equilibrium. That temperature is called my triple point, right? Is it clear to you? So for an example, if I'll say about the triple point of the water, then guys, it is my 273.16 Kelvin. 273.16 Kelvin. Is it clear to you? Here, I want to tell you an important thing. Please write down this, and if you have any doubt in this, please let me know. If you have any doubt in this, please let me know. So what is the triple point? So you heard about the freezing point, you heard about the boiling point, right? Is it clear to you? Now this one is my triple point. So as I told you, that triple point of the water is my 273.16 Kelvin. Okay? 273.16 Kelvin. This is my triple point of the water. At this temperature, guys, all the three phases of the water is basically coexist. Okay? Now, see, we have studied the scales. Here, this is my degree Celsius scale, and this is my Kelvin scale. Okay, 0 degrees Celsius is equal to 273.15 Kelvin. Yeah, is it clear to you? What is that? I'm saying 0 degrees Celsius is equal to 273.15 Kelvin. What is this 273.16 Kelvin? What is the difference between this value and this value? So in the interview, if interviewer will ask you that tell me 273.16 Kelvin and 273.15 Kelvin is the same thing, or we can say okay, approximately this is there is you can say that no problem, we are okay with it. So you will say if you are looking it through the mathematics, then there is no, you can say that there is no any a big difference, right? Only it is 0.01 Kelvin is the difference. Is it clear to you? But yeah, conceptually, as an engineer, there is a very big difference in the 273.15 Kelvin and 273.16 Kelvin. Okay, at 273.16 Kelvin, at this temperature, all the three phases are coexist, guys. All the three phases are coexist. Is it clear to you? Arey bhai, see, just try to understand. I'm comparing these temperature. Okay, I'm comparing these temperatures, 273.15 Kelvin and 273.16 Kelvin. First of all, tell me what is the difference. See, triple point is the temperature at which all the three phases of the substances coexist in the equilibrium. Okay, if you will take the example of the water, then at the triple point of the water, what is the triple point? It is 273.16 Kelvin. This is the triple point. This is the triple point of the water. At this temperature, you will see water. There is solid water, means you will see some ice, you will see some liquid state of the water, and you will see some vapors at this temperature. At this temperature, right? So at what is the meaning of triple point? Triple point means all the three phases are coexist in the equilibrium. Every substance has its different triple point, right? And in the most of the cases, as I already told you, that we will take the water as an example because it is easier for us. So the triple point of the water is 273.16 Kelvin. Now I'm comparing these two temperatures, 273.15 Kelvin and 273.16 Kelvin. Can you tell me what is the difference? What is the difference between these two values? Boli. What is the difference between these two values, guys? See, what is this? This is only 0.01 degree Celsius. And this is my 0 degree Celsius. The difference is, you can say, not a big difference, right? So what I'm saying, that in the interview, if interviewer will ask you a question that Mr. 273.16 Kelvin and 273.15 Kelvin is the same thing, or is there any big difference? So if you have the knowledge that this mathematically the difference is not so much, but conceptually it is a very huge difference. At 0 degree Celsius, the state of the matter can be the solid, but at the 273.16 Kelvin or at the 0.01 degree Celsius, at this temperature, water exists in the all three phases. So the difference is not in the number, the difference is in the state. This is a very huge difference actually. Right? Is it clear to you? So if let's suppose this is my reference line, this is my 273.15 Kelvin and this is my 273.16 Kelvin. Is it clear to you? right? Is it clear to you? So this is basically your triple point. This is the basically your triple point. Okay, so triple point means where all the three phases are basically coexist. Okay, okay, now based on that I can define 1 Kelvin also. So if somebody is asking define 1 Kelvin, if somebody is asking define 1 Kelvin, so what is 1 Kelvin? What is 1 Kelvin? Based on the triple point we can define this, yes or no? So we can say that 1 Kelvin is defined as 1 by 273.16 of the triple point of the triple point. Okay, is it clear to you? And if we will talk about the temperatures kind of property, then temperature is my intensive property. Temperature is intensive property. So this is all about the temperature, guys. This is all about the temperature. If you have any hurdle, you can ask. Okay, can we move forward? Okay. Please write down the heading state. Please. Can you write a sentence formation for the difference in the temperature of 0 degree and 273.16 Kelvin? I didn't get you, Muhammad. What are you trying to say? What sentence formation? I mean, there is no requirement of any sentence formation here. You can see here mathematically what is the triple point in the Kelvin. It is 273.16 Kelvin, right? What is this 0 degree Celsius? In the Kelvin, it is my 273.15 Kelvin. This we already talked about. Okay, so this is showing 0 degree Celsius. This is showing 0.01 degree Celsius. Right? What is this? This is the only difference. I only write the difference. So what should we write here? The sentence. There is no requirement of any sentence here. Right? I just try to compare the 0 degree Celsius and 0.01 degree Celsius. I here basically make you understand that there is a difference in 0 degree Celsius and 0.01 degree Celsius. Mathematically, that we can say mathematically the number is not significant, the difference is not significant, but conceptually the difference is very big. At 0 degree Celsius, the water may be in the only ice state, or you can say in the only the solid state, right? But at 0.01 degree Celsius, the water is present in all the three phases. So in this context, in the phase context, these two values are having you can say huge difference. Okay, this is what I'm trying to say, right? Okay, now please write the topic state. What is the meaning of state? Please write the heading state. Okay, so what is the meaning of state? Multiple times I talked about it in the thermodynamics, that this is in this state, this is in this state. What is the meaning of state? So the definition is very clear, that the state of the system is the condition of a system at a particular moment, right? At a particular moment, and that particular moment we will describe or explain with the help of the thermodynamic properties like pressure, temperature, volume, etc. Is it clear to you? So what is the meaning of state of a system? How we define the state of the system? Let's suppose that this is my any cylinder and gas is filled in this cylinder. At a particular moment, I want to explain its state. So how do I explain its state? I will explain its state with the help of the pressure, temperature, volume, or any property of the system, any thermodynamic property of the system. So at a particular time, I will say that, okay, the pressure of the system is P1, the temperature of the system is T1, and the volume of the system is P1. So through the thermodynamic properties, we basically define the system. We define the state of the system. Okay, is it clear to you? Second, equation of state. Equation of state. So what is the meaning of equation of state? So very simple meaning. State means that we are defining the thermodynamic properties of the system at a particular moment, like temperature, pressure, and volume, right? So there should be a relation in between the properties, like in the pressure, in the temperature, in the volume. So there should be a relation between these properties, which is basically defining the state of the system. That is called your equation of the system, equation of the state, right? So what I'm saying, an equation of the state is the mathematical relation that connects the thermodynamic properties of the system, such as pressure, volume, and temperature, right? And helps it describe the state of the system. Okay, so please write it, and if you need any further clarification, tell me. So in the equation of state, we should build a relation between the P, V, and T. At a particular point, the different values of P, V, and T defining the state of the system. Okay? Clear? So now we should have build a relationship between P, V, and T. P, V, and T. Is it clear to you? So at a particular point, at a particular moment, there should be a specific value of P, V, and T. Right? There should be a particular value of P, V, and T. Is it clear to you? See what I'm trying to say. I'm saying that we have three properties, and you can say most of the time we're defining the system with the help of pressure, volume, and temperature. So we do have these three properties. We do have these three thermodynamic properties. Is it clear to you? So there can be any combination. It means for any system, it may be possible that we have the P and V value. Through the P and V value, we can calculate the temperature value. It may be possible that we have P and T value. So with the help of P and T, we can calculate V. Similarly, through the P and V, we can calculate the P. Is it clear to you? So for the calculating the third parameter, we should have a relation in between them. So equation of state will give us that particular relation. Right? Now, just defining the state, guys. See, so here you can see this is my diagram. At y-axis, this is my pressure, and x-axis, this is my volume. Okay? Right? And these are the four state of the system: 1, 2, 3, and 4. These four are different state of the system. Right? Let's suppose that this is my any cylinder piston arrangement. Okay, and a gas is filled in this cylinder. At a different moment, we record the value of P, V, and T. And one particular value, we will say that this is the state of the system for now. Right? So, at one state, the value of the pressure is P1, V1, T1. Right? At the point 2, the pressure value may be P2, V2, T2. At 3, at 4, similarly. So, these four are different state of this system. Is it clear to you? These four are the different state of the system. I hope that this is clear to you. Am I clear with this or not? Please tell me. Yeah, Muhammad. Am I clear with this? Please let me know. Am I clear? Okay, great. Okay, so we can write that each point represents its unique state. Each point represents the unique state. Okay. Please write it and tell me. Please write it and tell me. Once you write it, let me know so that we can move forward. Yes, done, Mohammed. See, so we are talking about the equation of the state. Okay, so let's discuss about the equation of the state. Yeah, so the equation of state means that we should build a relationship between P, V, and T. So if I will talk about the ideal gas, then the relationship between the ideal gas, where the ideal gas property is PV is equal to nRT. Right? And I know that you guys are aware about it. Is it clear to you? See, so this is defining a particular state of a particular moment. Means for a fixed value of P, there will be a fixed value of V and there will be a fixed value of T. Is it clear to you? Is it clear to you? Like I'm defining a one state. So P is my absolute pressure. P is my absolute pressure. What is the value of that absolute pressure? It is my 101.325 kilonewton per meter square, or you can say kilopascal. Okay, is it clear to you? Now at this pressure, the volume of the ideal gas occupied is 22.41353 meter cube. So ideal gas at this pressure, it is occupying this much volume. And what is the temperature? Temperature is 273.15 Kelvin. There is no need to remember all these values. Okay, just if you want to remember, then remember up to the 2 digit. That's it. Okay, what about the N? N is my number of moles. N is my number of moles of the gas, right? And the unit of the number of moles is kg mole, kilogram mole. What about R? R is my universal gas constant. Universal gas constant. What is the value of universal gas constant? It is my 8.314 kilojoule per kilomole per Kelvin. Right? So the units are very important here. Here I defining the pressure in this unit, volume in this unit, temperature in this unit, moles in this unit, and R in this unit. If these are the units, then these are the fixed value. So all this value is basically defining a state of a gas at a particular moment. Okay. So this is the equation of state, or this is for the ideal gas. So also this can be called ideal gas equation. Ideal gas equation. So this equation is basically defining the state of the ideal gas. Right? Is it clear to you? This equation is defining the equation of state of the ideal gas. So this equation is in the number of moles. We can write this equation in the different form also. That form is, if I want to write this equation in the mass of the gas, then also we can write this equation. How? I will tell you. Please first just write it and tell me. Please write it and tell me. Okay. So this is the ideal gas equation in the number of moles form. There is another form. You can say in terms of mass of gas. So ideal gas equation is written as PV is equal to MRT. PV is equal to MRT. Now this R is different and M is different. P is same, P is pressure, V is volume, T is temperature, there is no change. M here is my mass of the gas. And this R is not universal gas constant, guys. No, it is, see, I just try to write in a different way. The symbol of R is this, and this is the different symbol. Okay, what is this R? This is called characteristic gas constant, or It is specific gas constant. How we get the value of this characteristic gas equation? Characteristic gas constant value. How we get this value? Can you tell me how we get this value, guys? So my R specific gas constant is equal to R, which is my universal, divided by M. What is M? M is my molar mass of the gas. Molar mass of the gas. This is my R specific. This is how we calculate the R specific. Is it clear to you? Okay. Okay. Yeah, Mohammed, tell me one thing. What is the molecular mass of the nitrogen? What is the molecular mass of the nitrogen? What is the molecular mass of the molar mass of the nitrogen? What is the value? What is the value? So we know the number, that is 28, right? All we know this number 28. Molecular mass of the nitrogen is 28. But I'm saying what is 28? 20 gram, 20 kilogram, 20 centimeter, 20 meter watt. What is the value? This is important here. And most of the students are not aware about it. They are just randomly put the value of molecular mass and calculate the question without thinking about it, that what is the unit and in what unit we should put this 28 in the particular formula. So what is 28? Gram per mole. So actually 28 in actual is kilogram per kilogram mole. Kilogram per kilogram mole. This is my molecular mass of the nitrogen, right? Okay. So for an example, if I will calculate the R specific for the air. R specific for the air is, guys, if you want, you can remember this value. It is my 287 joule per kg per Kelvin. This is the R specific for the air, right? So you can say what is the unit of R specific? R specific unit is my kilojoule per kilogram per Kelvin. This is the unit of the R specific. Okay. Right. So this is my equation of the state. So state is what? State means that we are defining how we define the state of the system by telling the thermodynamic properties like P, V and T. If we connect P, V and T, that is called equation of state. There are number of equation of state. There are number of equation of state, out of which we have for the ideal gas we use the PV is equal to nRT. This is the ideal gas equation of the state, right? And this is the another different form of the PV is ideal gas equation, that is PV is equal to mRT. That is PV is equal to mRT. Is it clear to you guys? Right? Can we move forward? Can we move forward now? Can we move forward now? Okay. Now, so now we have seen what is the state, what is the equation of the state. Now please write down the process. What is the meaning of process? What is the meaning of process? So we have these three properties P, V and T. Okay, and at y-axis it is P, and at the x-axis it is my V. And we have, you can say there are 2 or 3 or more states. There are different states actually. Okay, so we are moving from one state to another state. If we are moving from one state to another state, like this, okay, so this is my one state, this is my two state, this is my any third state, and this this is my process 1, this is my process 2, this is my process 3, and this is my process 4, right? So let's suppose this is any state, this is any state having some different value of P, V and T, P1, V1, T1, and let's suppose it is my P2, V2, T2, and here let's suppose it is my P3, V3 and T3. If we are moving from one state to another state, that is called my process. If you are moving from one state to another state, then it is called my process. Like, is it clear to you? So these are my process. This curve is also showing process. This is also any process. This is also any process. This is also any process. Is it clear to you? Sir, how the RSP of air value you denoted? कुछ नहीं बेटा, just denote when कुछ नहीं किया. RSP and bracket में air लिखा है. I just write the air. ऐसे लिखा है मैंने. Okay. Just divide the 8.314 divide by the molecular mass of the air, and you will get this value. Right? Okay. Yeah. So this is called by process. This is called by process. So each curve here represent the unique process. So what is the process? If we are moving from one state to another state, that is called my process. Okay, that is called my process. So here each curve is basically my thermodynamic process. Okay, let's suppose I'm saying that let's suppose this is my P and this is my V, right? This is any one state, right? Here it is my, let's suppose pressure is P1, V1, okay? And this is my another state. Here it is my P2, V2. Is it clear to you, right? So if we are moving from 1 to 2, this is my process. This is my process. Is it clear to you? Let's suppose you are moving from, this is my P and this is my V. Let's suppose this is any state and this is another state. This is state 1, this is the state 2, and you are moving from 1 to 2. This is also called process. Okay, this is also called process. Is it clear to you? This is also called process. If one term is also we define here. That is called here is P, it is V. Okay, let's suppose this is my any state 1, this is any my state 2, and this is my any state 3. Okay, just please pay attention here. So from one I'm going to the state 2. This is my, I can say this is any process. From 2 to 3 I'm going from 2 to 3, and from 3 to 1 I'm going from 3 to 1. Is it clear to you? This is called thermodynamic cycle. It is called thermodynamic cycle. So what is the meaning of cycle? Meaning of cycle means that my initial and final state are same. Initial and final state are same. So initially you are starting with 1, so this is the state 1, and after doing some processes, you are again at the state 1. So in the cycle, my initial and final state are same. Is it clear to you? Is it clear to you? Okay, so if I'm asking a question, guys, to you, that how much minimum process is required to complete a cycle? Can you tell me the minimum processes required to complete the cycle? Please tell me. Please tell me. Minimum processes required to complete the cycle. Give me the number. 3, 4, 5, 6, 7. What? What is the number? What is the number? What is the number? Please let me know, guys, what is the number? बोलिए. What is the number? Guys, very simple. Tell me one thing. 4. Yeah, Mohammed, how it can be possible? This is my thermodynamic cycle. 4 is not possible at all. This is the process 1, this is the process 2, this is the process 3. You can see here that there are at least there are 3 number of processes. Okay, but in actual, what is the value? Let's suppose this is my state 1 and this is my state 2. What I gave you the definition of the cycle. If the initial and final state are same. Let's suppose my initial state is 1. So I am basically going from 1 to 2. This is my process 1. This is the process number 1. So going back from 2 to 1. Just go from 2 to 1. Now my initial and final state are same. This is also called thermodynamic cycle. Yes or no? How much processes are required? 1 and 2. So there are 2 minimum. There are 2 processes required to complete a cycle. To complete a cycle. Okay. Is it clear to you? Yes. Is it clear to you now? Okay, so this is it from my side for the today's class, guys, and I hope that you enjoyed the class, and just tell me, revise it. We have completed the 4 lectures, so please revise it from the initial page and let me know that if you have any hurdle, if you have any you can say difficulty to understand anything, right? So today we discussed so much points here, that we discussed the absolute zero temperature, we discussed the triple point, we discussed the state, we discussed the equation of the state, we discussed the your can say the your state, we discussed the processes, we discussed the cycles, right? All these things. So these are the small things which you have to remember, guys, right? So just revise it. This is only your foundation, and the foundation must be so strong. If your fundamentals are so strong, then we can solve any kind of difficult question. But if your fundamentals are not strong, we cannot solve any very simple question, guys. Right? So it is very necessary to revise the fundamental things. Okay? And please let me know if you have any problem. Thank you so much. Bye bye and take care. Right? Let's meet in the next class. Okay? Yeah, more probably there will be no class tomorrow. So just revise all these 4 lectures and let me know if you have any hurdle in the Telegram group. Okay, thank you so much, guys. Bye bye. Take care.